Welcome guys to today's tutorial. We'll be looking at, or reviewing should I say, straight line graphs. We're going to be looking at the 2002 HSC paper, question 26C. A class of 30 students sat for an algebra test and a geometry test. The results were displayed in a scatter plot and a line of best fit was drawn as shown above. Okay, so for this question you can see clearly here that we've got a scatter plot, and we've got a line of best fit, which hopefully remember it's where you have the dots on, same amount of dots on each side basically. Okay, so if we look briefly at the very first question, okay, which says how many students scored less than 30 on the algebra test. So, okay, first of all, we need to look at algebra test. It's on the x-axis. We want less than 30, so obviously we've got 20, 40, so 30 is in the middle there. One of the easiest things to do, if you get a ruler, and you just draw a dotted line, just as I've done there, and you can clearly see on the left-hand side is where the students' scores are less than 30, and so we have there 1, 2, and 3 scores. Okay, so in that case, we only have, we only have 3 scores. Our second part of our question then asks us to calculate the gradient of the actual question, or of that straight line. So what is a gradient? Okay, hopefully remember the gradient is the rate of change, or how steep that particular line is going to be. Hopefully also remember that the formulas for the gradient, or the basic one, which we've learnt for some time, is rise over run. The more advanced formula is change in y over change in x, or in layman's terms, y2 minus y1 over x2 minus x1. Okay, so hopefully remember that in order to find the gradient, we need to have 2 points that are on the line. Now sometimes, some of the harder questions, there won't be any of the actual set points on the line, so you'll actually have to put, you have to put your points. For example, I could put a point here at 2020. Okay, but in this instance we actually have 2 points that are clear on the line, so we may as well use those 2 points. It's a good idea each time to write those points down. So this point here is a point 40 and 30. Okay, 40 and 30. And the second point is 80 and 50. The reason why I'm writing them down, not just makes it easier to read and to do this question, but often they won't mark you for the actual the points. They'll mark you for finding the gradient from that point. So even if you write the wrong points down, you'll probably still get the marks there if you apply the correct equation, obviously, or formula to get the answer. So in this case, we want to find the gradient, which is our y2 minus y1. So 50 take away 30 over 80 take away 40. Very important to have your y over your x, your rise over your run. And if we simplify that down to 20 over 40, or 2 over 4, or 1 over 2. So we've now worked out there that our gradient, our m value, is 1 over 2. Okay, 1 over 2. Now, if we just go back briefly to what we're working on here, the next part of our question asks us to find the equation of the line of best fit. Now, sometimes they won't actually even ask you to find the gradient. They'll ask you simply to find the equation. Hopefully remember, in order to find the equation, we need the gradient and we need the y-intercept. So you need to have done that first part first of all. But we've got that gradient bit. Okay, we've got that gradient bit. So that's the first part. We now need to find our y-intercept. So hopefully remember the formula y equals mx plus b. So let's just chuck in our gradient of a half into that formula. Y equals a half x plus b. Okay, now what is the y-intercept, or how do you find it? The y-intercept, to hopefully remember, is where it cuts the y-axis. Now we could extend that line, and if we extend that line, I could probably estimate it's going to be around about 10, but it might not be exactly 10. So it's really important that we do this method. We've got 2 sets of points, and what we want to do for our x and our y value, or either set of points is fine, we're going to put those x and y values into the equation, because what that will leave us with is one unknown which we can solve. So I'm going to use the first set of points. So we're going to put 30 equals 0.5. Now remember, a half x is a half times x. So half times 40 plus b. Now, if you like to use your equations editor on your solving mode of your calculator, that's fine. But to be honest, this is a pretty easy question because a half of 40 is simply 20 plus b, and then obviously you can see that b does equal 10. So actually our estimation to start off with was actually correct, but I would always do it this method because it makes an exact account. So we've now found our b value there, so our third part as 10, so we can simply write it in as y equals a half x plus 10. Remember that the half was our gradient from question 2 and our b was our y-intercept that we just found that last part of the question. Question 4 should be a nice easy one. It says describe the correlation between the geometry test results and the algebra test results. In this case we're going to have a positive correlation. Okay, might be double R there. Okay, so positive correlation. Hopefully remember that as x increases, you can also see that y is increasing. So they're both increasing, so it's a positive correlation. Last of all, we have, it says, Mitchell looked up the scatter plot and said, in this class, all students who are near the top in algebra are also near the top in geometry. Explain why his statement is incorrect. Now, one of the key things here is this first part, this word here, that 3-letter word, all students. So it says all students who are near the top in algebra. So let's have a look at the top of algebra. We've got all these people here at the top of algebra. They're all very close to getting 100. But you'll also notice that this little man out here, he's not very high up on the geometry scale of things. So what we could say there, in any sort of statement, there is one score that got algebra near 100, but only, let's say, what's that going to be, about 30 in geometry. Now, it's a very rough sort of comment, but anything saying that is an outlier which has an algebra result of nearly 100, but is also quite low on the geometry. So that one sort of comment that he made, because he put all, can't be correct. So look guys, I hope this gave you a bit of a review. Try some more of the questions in the HSC papers, and yeah, just keep on practicing. Make sure you remember the y equals mx plus b, and particularly on how to find the gradient.